Are we good here?
Yeah.
So far, so good? All right.
Yeah, I don't know. You're like the superior. Like the short part. My sister applied to this.
Mr. Bass,
Yeah.
can I look up all the world's records?
My sister applies to
about
this.
holding your breath in underwater?
Sure.
It's gonna be the freediver. Cause they swim like Olympic swimming pool in one
Why
breath.
are you laughing?
They do it like twice down and back. So they're
You want to know the first time I did what I did there? Jump straight in.
He didn't know because Wayne was singing
Because Spain's
Ladies, I'm gonna ask.
Too much drama.
I'm gonna ask that you refrain from whatever's happening.
That doesn't count.
I'm a little distracted. All right. So
How do you just get a thing of pure oxygen?
How do we know how much force the water is pushing up there?
24 minutes. But she breathed pure oxygen before doing it.
Yes, so it doesn't.
Achilles principle.
I mean, it counts.
It counts, but like,
I mean, it does, but like.
are you guys
it's
ready?
not like,
How do you pronounce that?
Archimedes.
Archimedes.
So here's what I want you guys to do. Get out your Googlers real fast. Okay. And what I would like you to do is I want to answer this question. Like, you put something in water. We know how much it weighs, but we got to figure out how do you figure out how much force the water pushes up with? If the water pushes up with more than the thing weighs, it'll float. If the water pushes up with less than the thing weighs, it'll sink. So how do we figure out how much the water is going to push up with? To find this out, we're going to explore something called Archimedes' principle, of course named after Mr. Principle. And let's see if we can't break this down.
So are we searching up the question or the term?
Look up the term.
We're talking about when you said Pythagorean theorem, you know, you square theorem. That was funny.
FE equals negative PG.
That actually, my high school biology teacher was a little bit of a character, and we studied something called the Punnett square.
Oh yeah, we do that.
Yeah, and of course he said it was named after Mr. Square, which I thought was
Genetics.
hilarious.
Oh my gosh, those are really.
I don't know, I don't have it. 23.
Okay.
All right.
Archimedes' principle states that the upward buoyant force that is exerted on a body immersed in a fluid, whether fully or partially, is equal to the weight of the fluid that the body
Yeah, I don't know what this
displaces.
I know.
It means that the water.
All right, hold on. Let's do one thing at a time.
The water displaced by the object.
So
if you filled it up.
we're gonna start here.
Water spills out.
Okay. We're gonna start here, and there's something that I think you know. There's something that I think you know, but I just want to make sure. Okay, there's something I think you know, but I just want to make sure. So I'm going to draw a graduated cylinder. Okay. You guys know what a graduated cylinder is? It's a cylinder after high school.
It's kind of cool. Like why?
Okay. So
FB equals negative PGB. What does that mean? Buoyant force equals buoyant force. See, it is a force.
No, buoyant is the name of the force.
Yeah.
that's the nickname.
Equals fluid density times acceleration due to gravity times fluid volume. Is that right? Google's so smart.
All right, you guys ready?
What is that?
So what I have here is I have a graduated cylinder, and it's got some liquid in it. And what I'm going to do is I'm going to take my little cube, okay, and I'm going to put it in my graduated cylinder. Okay. And it falls to the bottom, and I would like to know what happens to the water level. Does it go up?
Yeah.
Why?
More mass.
Because volume is increasing.
Volume equals
The
something.
buoyancy force is equal to the
Because
weight of the fluid water.
Because that the space that the cube takes up is going to have to be made up for.
Yeah, that's what actually what Cole says. He says now you added more actual matter to it, and matter can't take up the same place as some other matter. It has to go somewhere, so where does it go? It goes up the column.
Like when you put ice in your water, that's why it makes the glass more full.
Yeah, actually, so we have here a difference,
But it floats, yeah.
okay? We have here a difference in volume. Oh gosh. It says delta volume. Now, I understand that the water goes up the column. There seems like there's a difference in height there of the water, but consider the fact that it's actually a change in volume because you have an area of the base times the height would give you the volume. So that's how these things work. How do you think this change in volume of the water, like you could read it right off here. For example, if this right here said 50 and this one here says 70, what would be the change in volume? It'd be 20. So it'd be 20, usually these are measured in milliliters, yeah?
Yeah.
How do you think the change in volume as registered on the graduated cylinder compares to the actual volume of the cube?
Equal.
Check your neighbor now. See if this is something your neighbor understands. What's that? I hope that you've actually done this a couple different times. Yeah.
I had a bad physics teacher.
In middle school?
Whoa.
Yeah, is it middle school?
Yeah.
We did not do this in middle school, at least my class didn't.
And my teacher is retiring.
We have Mr. McIntyre.
We did chemistry and biology.
How do the two volumes
Is
compare?
there the volume ratio of?
It's the weighted displacement.
I just want to know how the two volumes compare.
Equal.
All right. This is an actual term that you're going to need to know. This change in volume here, this is called the displaced volume. Okay? And it's equal to the volume of the object. Okay? So, and you may have done this. This actually, I think, is a piece of information that is either really intuitive or is part of your past experience. If you put a 1 centimeter, a 1 cubic centimeter cube into there, the volume would change by 1 milliliter, because those two, that's the same measurement. 1 cubic centimeter, same as 1 milliliter. Thank you all.
So a vote tomorrow?